Red Hat OpenShift 4.21. I am Michał Zasempa from OpenShift Product Management team. Together with my colleagues, we are excited to share some of the powerful new capabilities coming your way in this release. Let's start from the big picture. How Red Hat OpenShift forms the backbone of the open hybrid cloud. At the very base, everything runs on Red Hat Enterprise Linux, the host operating system that powers our entire platform. On the top of that sits Red Hat OpenShift, our enterprise-grade Kubernetes platform. This is where Red Hat takes upstream Kubernetes and make it ready for production at scale with automation, security, and governance baked in. You get all the power of Kubernetes, but with integrated capabilities like service mesh, GitOps, pipeline, serverless observability, and cost management, all working together out of the box. As your footprint grows, OpenShift Platform Plus builds on the foundation of with multi-cluster management, centralized security policy, and global container registry. So you can manage fields of clusters across hybrid and multi-cloud environment with confidence. For developer, we offer the Red Hat Advanced Developer Suite. This includes tools like Developer Hub, security software delivery, and AI-assisted development workflows that makes building, deploying, and managing apps much faster and safer. Then there is Red Hat Applications Foundation, our middleware and integration layer that helps connect systems, manage APIs, and modernize existing applications. At the top of that stack, Red Hat AI. This is where applications development meets intelligence, model trainings, fine-tuning, retrieval augmented generation, agentic workflows, and more, all runs on OpenShift. It's how organizations bring AI into the production using the same hybrid cloud platform they already trust. Finally, all of these can run anywhere, self-managed in your data center, or fully managed through AWS, Azure, Google Cloud, or IBM Cloud. This is the power of Red Hat Open Hybrid Cloud. One consistent platform for your application and AI workload built entirely on open source. Over to Nick to talk about what's new in base Kubernetes 1.34.
Good morning, everyone. So for OpenShift 4.21, it is based on the CRI-O 1.34 and Kubernetes 1.34. Kubernetes 1.34 is titled Of Will and Wind. Some of the notable features graduating to stable are the dynamic resource allocation core, and this will bring much more flexibility and fine-grained control to resource requests. Imagine ordering one car versus a blue SUV with heated seats and all-wheel drive. Additionally, we have improvements to pod replacement policies. These new policies will enable the creation of a jobs replacement pod to be delayed until the previous pod has fully terminated. This will be highly valuable in resource-constrained clusters. Additionally, we have a new API object called the volume attributes class, and this will enable administrators to define performance profiles for their persistent volume claims. And finally, we bring some improved configurable authentication. This will have a dynamic file-based configuration, allowing multiple identity providers, configuration reloads without restarts, and additionally, powerful CEL-based validation rules for the API server. There are a few notable beta features. This will include the non-core dynamic resource allocation, as well as external service account token signing, pod-level resources, and prefer same node traffic distribution. Next slide. So in addition to what's happening in the upstream, OpenShift 4.21, we are pleased to announce several product improvements that were driven by customer request. This slide shows the top requested enhancements delivered in this release. Firstly, we have an enhancement to the API server, which will allow the events TTL parameter to be configurable. This will help to improve performance of etcd by shrinking the amount of event noise. Additionally, we've made a significant effort to use UBI minimal as the base image for all OpenShift components. This improvement will help reduce the number of false positives coming from CVE scanners, as well as shrink Red Hat operators' overall exposure to vulnerabilities. Most operators have already migrated and will be available at GA, and we'll see the rest migrate in the subsequent weeks following. Finally, we have on the topic of pod resources, 2 enhancements that will help improve overall performance and scalability of OpenShift. And these improvements will allow you to modify pod CPU and memory resource requests in place. And additionally, the vertical pod autoscaler will be able to apply these modifications without requiring pod restart. Now, onto the spotlight section.
Thanks, Nick. Now let's talk about the spotlight features in OpenShift 4.21, the major update that shaped this release. We grouped all the most highlighted features in 3 groups. AI is the first one, when the main focus is on dynamic resource allocation. Also in core, we are introducing 2 important features for hosted control plane, dynamic scaling, auto-scaling to from 0. Additionally, we are happy to announce VMware Cloud Foundation support as a GA, and there are 2 other features related to OpenShift on Oracle database appliance and confidential containers for Azure. There is a lot of also features which are coming together with virtualization to support your journey. Now, Gover will share more about AI stuff which is coming in 4.21.
Thank you, Mikael. So we're excited that there are a lot of AI features coming in 4.21, especially around DRA. So first is DRA admin access. This allows admin to safely inspect the devices, example, do diagnosis, put in a maintenance mode. Another is alternative, prioritize alternatives. As an admin, you can define a list saying that, hey, I want to use this device. If this device fails, go to this device. So you can have a list of devices and have a workflow or rule around that. Another is the DRA feature is attribute-based GPU allocation. Now, an user can declare what devices like GPU they want to use based on the attributes of the GPU versus the name and model and type of the GPU. Another feature is around job set that we are GAing or general availability. Job set is a group of jobs that share common life cycle. Another important feature is around Red Hat built-up queue. In there, 1.2 is getting released, and we are supporting Qflow trainer jobs v2. Thank you. Next slide, next presenter.
Thanks, Gaurav. Let me go to the VMware vSphere Foundation and VMware Cloud Foundation announcement. So we are glad to share that it's now generally available. We are supporting OpenShift versions 4.18 through 4.21 along with ACM 2.15.1 plus, ensuring you have a stable foundation for your modern workloads. On the storage side, we've launched a technology preview for OpenShift Data Foundation 4.19.7 and 4.20 with plan for GA in Q1 this year, giving you a clear roadmap for persistent storage. For networking, we are using a standard 2-layer model. We are leveraging VMware NSX to ensure robust connectivity at the hypervisor layer, and we are using OVNK for overlay network. I encourage you to check our blog post linked on this slide. It's time to see what Martin will share about OpenShift virtualization.
Thanks, Michal. So on OpenShift virtualization, we focused mainly on usability and simplification. So we added features around multi-cluster VM operations and management to the ACM side. We redesigned and created a wizard and a new user interface for network connections, physical as well as virtual VM networks. In addition, we finally have eject and insert CD-ROM support as tech preview now in 4.21. And on the UI side, we did integrate with our generative AI Lightspeed in OpenShift to get information from that AI into the UI flows and for troubleshooting as well. In addition, we do now support UI plugins for third-party integrations, meaning we have an API for them so that they can easily attach their own UI into OpenShift virtualization. On the infrastructure side, there was some additions on the vGPU NVIDIA side, mainly support for MI GPUs, as well as we introduced a tech preview, the storage agnostic change block tracking. That's mainly needed for incremental backups to keep your backup sizes small. And we are now also GAing the cross-cluster VM live migration, which is supported by MTV and Advanced Cluster Management, where you can live migrate VMs across cluster boundaries. On the infrastructure side, we added support for the Google Cloud Bare Metal instance types, as well as a Windows Server failover cluster with multipath support. So you can now have multipath PVCs as a quorum device in Windows servers for the failover clusters. The networking side gets IPv6 single stack installation, so you don't need necessarily to have IPv4 anymore. And you can now also import VMs connected to any overlay network into OpenShift virtualization. And with that, I'll hand over to Simon, who will kick us off on intelligent OpenShift.
Yes, thank you, Martin. And let's start with right sizing. The upcoming Advanced Cluster Management 2.16 release includes right sizing recommendations as a generally available feature through multi-cluster observability, or MCO. These recommendations offer different levels of granularity for cluster, namespace, and virtual machines. So how does this feature work? Well, it utilizes ACM's built-in tools. MCO gathers CPU and memory usage data from all managed OpenShift clusters, including those running virtualization. Prometheus rules then evaluate this data to identify patterns over time period. And then finally, insights are presented in specialized Grafana dashboards. The benefits of this, of course, is actionable recommendations for optimizing resource usage, and it helps prevent resource waste. So it should make your cost efficient across your entire infrastructure fleet. We're very excited about this feature, and we're looking forward to receiving your feedback when you try this. With that, over to Sundakar and the next slide.
Yep, thank you, Simon. Now, let's take a look at what's new and available in AI accelerator ecosystem with OpenShift 4.21 across both NVIDIA and AMD. Starting with NVIDIA, OpenShift continues to strengthen support for secure and regulated environments. We support UEFI secured boot with pre-built NVIDIA signed drivers, which is critical for customers running secured boot with FIPS-enabled clusters. So early access started in early releases, and 4.21 builds on that foundation. From the day two operation perspective, OpenShift 4.21 supports NVIDIA GPU operator version 25.10.1. This brings updated GPU drivers, DCGM, the device plugin, and the MIG manager, along with improved stability during upgrades and node updates. At the platform layer, OpenShift 21 exposes the Kubernetes Dynamic Resource Allocation, or DRA API. This is a foundational capability that enables more flexible GPU allocation models beyond the traditional device plugin approach. NVIDIA also provides a DRA driver as a standalone component deployable via Helm charts. It replaces NVIDIA device plugin and is not yet embedded in the GPU operator, with the native integration planned for second half of 2026. On the AMD side, AMD GPU operator version 1.4.1 is GA now and published in Red Hat catalog. It adds support for AMD Instinct MI350X and MI355X GPUs with ROCm 7.2, along with disconnected or air-gap installs, along with improved kernel compatibility handling and fully functional OLM packaging right now. Starting with ROCm 7.2, the AMD GPU kernel driver is now decoupled with ROCm user space, enabling independent driver upgrades and downgrades, which is a big win for operationally. So overall, OpenShift 4.21 delivers a strong accelerated foundation today, while clearly preparing the platform for the next generation GPU management. With that, I will hand it over to my colleague Raman, who will walk us through manage at scale.
Thanks, Gaurav. So let me start by the roadmap for 2026, which is very important to understand these features that we have in 421. We have 3 topics in hosted control planes. The first one is ROSA HCP, which is going to be the default topology later this year. The second one is Arrow Azure managed as well, which we want to GA later this year. And the third one, in this case, is self-managed Azure, which you will see here. We are having a developer preview in 421. This is really important because while there's no scarcity of features that we want to add and we will add from our backlog, these 3 topics are our topics, top topics for 2026. Having said that, HCP on Azure, we have a developer preview. So as soon as we have 421, you are ready to start playing with it and providing feedback. We are adding control plane auto scaling for ROSA. That means there will be automatic scalability based on actual Cube API server memory usage. We will use the vertical pod autoscaler, and there will be optimal performance reducing over provisioning with this dynamic more or less size for the containers of the control plane. Then scale down to 0 node in ROSA hosted control planes. Is to basically can or rather the SREs to 0. So you can keep your hosted cluster with no nodes at all, right? So, and the same from 0, you can scale up to as many as you need dynamically, reducing compute costs when not needed. We are adding in self-managed, in this case, x86 control planes with ARM nodes. And back to ROSA, we are adding support for a global pool secrets. With this, users can provide a custom pool secrets for other catalogs, for example, that automatically merge with the cluster's global pool secrets. Right? With this, it enables access to both custom service managed registries without having to open a ticket and talk to the SREs for this purpose. Then Arrow HCP, again, key in our strategy for this year, so we need to be laser focused on it. And during this release, we are adding 15 features that will be part of our GA later this year. And finally, configure ingress route. So with this, you will be able to specify the endpoint publishing strategy, for example, load balancer, directly in the hosted cluster CR, which today you had to do on day 2 in a slightly less convenient way. So next slide.
All right. I'll be presenting the ACM 216 updates the engineering team has been working on for the upcoming release. We're happy to share that as part of the Global Hub Operator, the Managed Cluster Migration feature now has an integration with zero-touch provisioning. That's the cluster instance CR, and event-driven workflows leveraging cluster lifecycle provisioning and events. So now with the Global Hub agent running in each managed hub cluster, you can use the Global Hub agent to publish these events from each managed hub cluster to the Global Hub Kafka instance. So with this, EDA can consume the Kafka stream to receive the events. This allows for zero disruption ACM upgrades, as well as incremental migration of managed clusters. And lastly, control plane load balancing capacity redistribution. That's exciting. That brings together quite a few different OpenShift components. So we encourage you to take a look at that. We're also continue to enhance the user experience for managing virtual machines across the fleet. So we now allow secure access to VMs on remote clusters with the fine-grained RBAC for virtualization now being GA. As well, we've achieved GA for the cross-cluster live migration, which can be enabled via the add-on. Our goal is to provide a robust validation for reliable transfers. Next slide, please. Okay, here we have the GitApps add-on. It's now GA. This offers a flexible, easy to use, and native integration into ACM to install Argo CD into different clusters, including non-OpenShift clusters. This work with the Argo CD agent is where we also have GA planned in upcoming releases. Next, we have the cluster lifecycle management update, and this is around our work on the cluster API operator that's integrated into the multi-cluster engine, MCE. That's now GA. And we have providers for the CAPI operator, and CAPZ for RO will be going preview. And we also have monitoring and observability features for right-sizing VMs, including namespaces and clusters. That's GA. It was prior preview under 2.15. And then we also have the right-sizing for the VMs. Yes, that's GA. Next slide, please. Let's move on to Maria Simon from the ACS team. Thank you,
Brad. There are a lot of exciting features about ACS, but we are going to talk about the highlights here. One of the major milestones is the virtual machine for vulnerability management and scanning. We are tech previewing that. What this allows you is you are able to use vulnerability management from ACS in the same place that you used to run it for containers in the past for real virtual machines in OpenShift. This is kind of like supporting our OpenShift virtualization story. We are also introducing file activity monitoring on tech preview. This is a new feature that allows you to monitor the specific sensitive file paths at runtime. So it's not only telling you that some specific file has been modified, but it will also tell you who did it, which process, what, when, and it will also provide you the Kubernetes context in case the change has been originated by a container. To also streamline the platform engineering experience, we are bringing vulnerability management directly into the OpenShift console. We are doing this with an OpenShift console plugin. What's great about this is that you don't need to leave the OpenShift console at all if you want to look at the vulnerabilities for the specific scope you have access to. You can just go to a new section that will be open, will be called security, and under that, you will be able to kind of like scan through all the vulnerabilities. There will also be shortcuts in the different sections under workloads, etc. Also, in the vulnerability management space, we are adding a new policy criteria called DASYS CVE fix. This criteria can be used to prioritize patching vulnerabilities based on when the fix was available. And also we have another feature, which is base image separation of duties, which allows teams to identify quickly which vulnerabilities affect to the base image versus which vulnerabilities are in the application layers. And this is a regular issue and customer question and RFE that we have been getting. This is all for ACS highlights, and now we're going to move to Quay with Tony.
Thank you. Today I'm highlighting the major advancements in Quay 3.17. Our first highlight is organization mirroring. Instead of manual repo by repo setups, you can mirror entire namespaces. This automates content delivery from thousands of remote repos, removing the massive operational hurdle. Next, we are introducing tag immutability. This specifically is for teams who prefer achieve stability via image tags rather than digest. You can use regex policies to lock tags like v1.2 or release-stable, ensuring those human-readable references can never be overwritten or deleted. For disconnected environments, we are introducing sparse manifest support. Quay is ready to handle selective architectural mirroring, which will save storage space without breaking image digests. Finally, we harden our foundation by moving all images to UBI 9 minimum. It's FIPS ready, shrink our footprints, and cuts out CV noise. Check out the full release notes for more and claim your upgrade to Quay 3.17. With that, over to Simon for observability. Thank you.
Thank you, Tony. And we'll dive straight into Cluster Observability Operator, COO, which we envision to be the main entry point for most observability use cases. It should be an easy observability installation experience and allow users to benefit from enhanced observability features. It's designed to be highly customizable, scalable, and go beyond the default monitoring capabilities of OpenShift. It should also incorporate UI, plugins, and advanced analytics right in the web console. And with this 1.4 upcoming release, we have two new key features we want to highlight. The first one is customizable dashboard as part of the OpenShift console, powered by Persis, the open source dashboarding tool that leverages dashboards as code. So it supports metrics, traces, logs, and it's moving into a tech preview and will be provided as part of OpenShift subscription with no additional costs. We also have a brand new AI trace summarizer. This is released as a developer preview, and this AI trace summarizer is integrated directly into OpenShift Lightspeed and gives the users a chance to interactively ask Lightspeed about traces. Next slide, please. And yes, moving into monitoring. With OpenShift 4.21, we continue to invest in the monitoring stack with a strong focus on upstream alignment, performance, and operational correctness. This release combines meaningful Prometheus and Prometheus operator improvements with important fixes that improves day-to-day reliability for all users. We're taking concrete steps towards full UTF-8 support in Prometheus, which gives better internationalization and more robust handling of labels and metadata across diverse environments. We also improved OTLT metrics ingestions, continuing our work to strengthen OpenTelemetry support in OpenShift monitoring. This helps prepare the stack for more OTel native workflows. The release also includes PromQL and TSDB performance improvements coming directly from upstream Prometheus, which is especially important for large clusters and high cardinality. So all in all, like the most important thing is just closer connection to the upstream communities so that we can provide more of that value faster to our users while maintaining the enterprise stability that everybody expects. On the improvement side, Thanos ruler retention is now aligned with the user workload Prometheus. And this is before, if configuration was not done right, it could lead to a mismatch and gaps in alerting. This new behavior is much more predictable and less manual configuration. We also have updated a bunch of the monitoring stack components, bringing performance improvements, bug fixes, and security patches. So moving on to the next slide, and OpenShift logging. So on the log collection side, the new OTLP log export feature automatically enriches your logs with essential trace attributes, things like trace ID and span ID. And this allows SREs and developers to immediately correlate a log entry with the full context of the request. This, of course, greatly simplifies the debugging process, especially for complex microservice architectures. On the storage side, you can now easily change loci scale without recreating persistent storage. This not only simplifies day-to-day operation, but also ensures proper and efficient scale down of ingesters, which is critical for resource management and stability. And for users running complex multi-tenant hybrid cloud setups, we introduce an API to allow Loki Stack Gateway to be disabled. And this is purely about flexibility and security. It enables Loki Stack to run securely behind an alternative external authentication gateway, like the ones used by ROBS and MCOA. And this gives you precise control over tenant selection and routing in the most complex deployments. And next slide, please. And wrapping up the observability section with distributed tracing. And in 3.9, we're moving a number of components to GA. It's the filter processor, transform processor, and the metric start time processor. And filter and transform processor both use OpenTelemetry transform language. And filter processor is used to determine if signals should be dropped and not sent. And this is very useful to only save the signals that you need. The transform processor is used to change those signals before they are forwarded. And this can help you to meet security and compliance goals for your signals. The metric start time processor is something that will be great for all our GCP users. We now can send metrics to Google Managed Prometheus for just a better observability experience in GCP. We are also creating a more managed OpenTelemetry experience for new users. This will offer an initial guide to gathering signals with the Red Hat build of OpenTelemetry so that you have an easier time getting started with collecting important signal. And in tracing, we're moving to Tempo 2.9. This gives users more performant and efficient TraceQL search experience. And with that, I'm going to hand over to Ali to give us console updates. Thank you.
Phil. How are you today? Ali Mobram here. So in the 4.21 release, we have delivered on several top customer enhancement requests, focusing on administrator troubleshooting, user experience, and storage flexibility. First off, we added advanced user impersonation for RBAC troubleshooting. This means cluster administrators can now impersonate a user with multiple group memberships simultaneously. This allows for the exact reproduction of user effective permission, making it significantly easier to diagnose and resolve complex RBAC issues. Next, we improve the console YAML experience. This means we've enhanced the YAML editor by allowing users to select and save their preferred Monaco editor theme and font. Users can now toggle between dark, light, or system preference. Next, we added storage flexibility with volume attribute classes, also known as VACs. Similar to storage classes, they are applied to PVCs and remain immutable after creation. The key difference, unlike storage classes, a PVC-associated VAC can be updated. This allows users to modify the attributes of the underlying volume dynamically without recreating storage. And then finally, we expanded the console customization. The console link CRD now supports mail-to links. This enables administrators to add direct email us links within the console UI, streamlining communication with support teams. So that's it for me. Very nice to see you all again. And next slide, please.
Thanks, Ali. So in Red Hat Developer Hub 1.8, we focus on deepening the integration between RHDH and the broader Red Hat AI portfolio while giving platform engineers better tools to drive adoption. So for governance and compliance, we introduced the scorecard plugin in developer preview. This provides critical visibility into project health and compliance metrics directly within the portal. We also have versioning of the templates that is now supported, and app owners can receive notifications when the template is updated. To help you scale global adoption, we have added the localization support, starting with French. We also streamlined onboarding with a new quick start for the developer persona. We've made significant improvements in our AI capabilities. RHDH developer Lightspeed has transitions to the Llama stack for greater flexibility, and we've introduced the MCP server. This allows AI agents to securely access your RHDH software catalog and technical documentation to provide context-aware answers. We've also added OpenShift AI connector, which automatically syncs AI models and assets into the RHDH catalog. And finally, we've launched the Dynamic Plugin Factory to simplify custom plugins development. Please try it out and give us your feedback. And next speaker is Matt.
Hey, everyone. In the latest Podman Desktop release, the included Podman installer for Windows no longer requires admin privileges. This is a massive win for developers in restricted corporate environments. We also made onboarding easier for teams. You can now set up default container registries through configuration files, ensuring your developers can access internal registries right out of the box. On the UI front, we've significantly improved the experience for Podman remote connections and the task manager, alongside general performance boosts to keep the app snappy. Finally, on the Kubernetes side, we've added support for the replace flag in Podman Q Play, allowing you to do smoother iterative testing of your manifests. For a deeper dive, you can find the full details in the linked release notes. And with that, I'll hand it off to Mukhtar.
Hey there, so on the Dead Spaces, if you're unfamiliar with it, it's our cloud development environment platform that allows developers to remotely code and run applications using OpenShift. So we released 2 new versions since the last What's New, which are Threat 24 and Threat 25. So we'll quickly go over some of the new features. First up, we're excited to announce that we now support running nested containers in Dev Spaces, which allows developers to natively run containers and do commands like podman run without needing any workarounds. Next up, VS Code Local to Remote is now Tech Preview, which allows extensions from the official Microsoft extension store. This feature will run all code, compute, extensions, and the IDE server on OpenShift, while the local desktop IDE acts as a thin UI shell. And for our JetBrains developers who need to use multiple IDEs, we now support connecting multiple JetBrains workspaces at once. And lastly, for admins, we've added a new feature that allows admins to globally pre-configure default resources for all workspace containers. There's a lot more, so please feel free to go through our release notes, and onto you, Veda.
Hi, everyone. At its core, Red Hat Trusted Artifact Signer is a production-ready deployment of the 6-store project within an enterprise to enable cryptographic signing, attestations, and verification for all software artifacts. This means every component in your pipeline can be verified for integrity and non-repudiation. What's particularly exciting about RSTAS 1.3 is the introduction of the model transparency library that brings the same cryptographic protection to AI deployments. The RSTAS 1.3 also introduces the model validation operator, which helps in verifying models before they are loaded into the OpenShift namespace. For enterprise operations, we have introduced fine-grained, high-availability controls to configure pod affinity, set up multiple replicas, and define resource limits to handle peak loads or infrastructure failures. Finally, transparency and monitoring have been enhanced with continuous verification of our record transparency logs to ensure they remain tamper-proof, plus new cloud storage integrations with S3 and cloud storage, Google Cloud Storage for flexible attestation storage. In short, RSTAS 1.3 gives you comprehensive enterprise-ready protection across your entire supply chain, including your AI deployments. Next slide, please. The secure supply chain component in Red Hat Advanced Developer Suite makes it easier to set up secure development environment. It comes with ready-to-use templates in Developer Hub that help you to build safer CI/CD pipelines. Basically, it bakes security checks right into the development process, makes sure your artifacts have not been tampered with, and helps you meet important security standards like supply chain levels for software artifacts, also known as SALSA. Next slide, please, and let me hand it over to Jeff Beck.
Thank you very much, Veda. My name is Jeff Beck. I want to talk a little bit about Red Hat Build of Quarkus, which is included in Red Hat Runtimes, which is in the Red Hat App Foundations that you saw at the beginning. I want to talk a little bit about the version 3.2.7 release, which was released late last year. I have a link here if you want to look at more details, but in general, a couple of the main highlights are in updating the Hibernate libraries, including ORM 7, Reactive 3, and Hibernate Search 8. The main focus here was on improving performance, bringing up to speed and supporting modern Java versions, as well as seamless integration to do both traditional and reactive application development. Also, we have some subscription-aware tooling available via CLI or via the code.quarkus website. The key here was to allow customers to basically identify whether it's a supported or unsupported version, which allows them to track their compliance and those kind of things. Lastly, Chappy was introduced, which is an AI-powered assistant that enhances the developer experience while they are in dev mode. So it integrates with the dev UI and it offers AI-driven support during that development process. Lastly, I want to leave you with this, that we are in the planning stages for Red Hat Build of Quarkus 4, which tentatively is looks like it's going to be delivered either late 26 or early 27. So more to come on that. Next, I'm going to turn it over to Jamie.
Thanks. So starting with developer services, we'll start with Service Mesh. We're about to release OpenShift Service Mesh 3.3, which follows the introduction of Istio Sidecarless Ambient Mode. This release updates Istio to 128 and adds support for post-quantum crypto algorithms with Istio gateways. This is enabled using the MLChem algorithm that is now included with OpenSSL, which is the encryption algorithm behind OpenShift Service Mesh. We'll add support for data plane proxies in a future release. We're continuing to evolve ambient mode with support on FIPS clusters, and multi-cluster support is now tech preview. Looking to the future, we have some big features that will be available for developer preview soon. Kiali is introducing an AI chatbot that lets you query your mesh workloads using natural language questions. MCP integrations will allow you to use these features with OpenShift Lightspeed or an agent. Zero Trust Workload Identity Manager will extend Service Mesh's management of workload identities with deeper attestations at scale. Finally, we'll soon have developer preview support for including external VMs with OpenShift Service Mesh, a powerful feature enabling you to secure, manage, and observe your off-cluster workloads with Service Mesh. I'll now pass it to Carlos for builds and pipelines.
Thanks, Jimmy. I'm going to start the presentation highlighting the key updates of pipelines 1.21. First, introducing in dev preview an easier way to debug failed pipeline runs using OpenShift Lightspeed, where it will generate the root cause, but also recommendations how to fix quicker the issue. You see on the screenshot how we showcase this capability. Moving on, we finally released in GA the event-driven pruner and also detect on cache. On the security front, we have hardened the containers for controllers and webhooks by setting the root file system to read-only by default. Also, we have increased the flexibility in how you control the overall execution duration of your pipeline runs by overwriting individual task runs timeouts. We are enhancing our caching mechanism in the resolver. As a result of that, minimizing the redundant downloads and also the external API calls. Also, with this update, detect-on results will receive different rotation periods for pipelines and task runs based on namespaces, labels, annotations, and statuses being defined as policies. The first matching policy, it will be applied. If there is no matching, the default rotation period, it will be used. And last but not least, on the builds, the build config for the zip-write migration guide, it becomes available. There is much more, so please check out the release notes. And with that, I move on to serverless. So Phil, please take it away.
Could you go to the GitOps slide? I think we skipped over one slide. It's a little bit of a mix-up with the order. Thank you, Carlos. OpenShift GitOps 1.19 is released alongside the OpenShift 4.21. In this release, the significant feature is the Argo CD agent that has reached GA status, generally available. Argo CD agent enables customers to move away from a single cluster control plane of Argo CD and be able to have an Argo CD control plane in a hub and have agents on clusters that need GitOps capability, and those agents phone back and connect to the hub for reporting status, and be able to scale Argo CD control plane to many more clusters rather than a single cluster architecture. It significantly improves the scalability of Argo CD across the fleet. The second area is image updater that is released as tech preview. Image updater automates the process of updating images in a registry. Let's say Quay and Argo CD automatically would know that a new version of the same image is available in Quay or any other registry, and goes and updates the manifest to redeploy that image. It's very useful for especially development, pre-production environment when there is a high churn of rebuilding images, and you don't necessarily want to manually go update a manifest in a Git repo to roll that out to your cluster. So it's highly sought, and we brought it to preview in this release, so we'll GA throughout the year. And the next area we'll bring to your attention is the delegated notification management. And in the past, for using Argo CD notification, that required a cluster admin privileges to configure that for each of the namespaces instances. Now, some of that configuration is delegated to the project admin, so the teams who are a tenant of a cluster will have the ability to own some of that configurations. Next slide, please.
All right, thanks, C-Mac. This is for OpenShift serverless. We've synced serverless 1.37 release with OpenShift 4.21. And here's some of the updates that we're including. We're incorporating numerous improvements to serverless core components following Knative's 1.17 upstream release. This includes updated default configurations for serving, making it easier to install and deploy serverless for your OpenShift environment. We've also added eventing support for generic event sources and sinks using Apache Camelets. We're also making multiple minor resource optimization fixes that should enhance the overall serverless performance. Now, some exciting news, serverless functions, MCP server, will be available for developer preview. In this feature, serverless functions can be utilized as an MCP server via the serverless CLI using the command funcmcp. This feature offers full coverage of serverless function features via MCP, as well as context injection via MCP prompts. We're also providing integration with our serverless functions template repository, including a Python POC for experimentation. Furthermore, we're including integration with popular AI tools such as Windsurf, Cursor, and Cloud. Finally, serverless integration with OpenShift Service Mesh 3 will be available in technical preview. With this, we'll be providing a migration guide from Service Mesh 2.x to 3 on serverless, as well as new setup guides for Service Mesh 3 on serverless. And now over to Ramon for the next slide, please.
Thank you, Finn. Okay, so for MTA 8.1 arriving late Q1, we are focusing on bringing a platform engineering approach to migration and modernization. First, we're introducing centralized configuration management. This allows organizations to bake their own corporate standards and custom migration rules directly into the platform, ensuring every team modernizes the same way at scale. Next, we are bringing both MTA and developer lightspeed for MTA to OpenShift these dev spaces in tech preview. We're moving beyond just IDE plugins to provide a full modernization as a service experience, where AI-assisted refactoring is pre-configured and ready to go in the browser. Finally, for our .NET users, we're launching a new .NET provider in dev preview. The big news here is that you can now analyze legacy .NET Framework applications without requiring Windows containers, significantly lowering the infrastructure bar for those initial assessments. Now over to Mark Russell.
Hey folks, the big CoreOS news this release is that we are introducing a tech preview of 2 features in one, both the introduction of RHEL 10 itself, and just as importantly, the ability to run 2 different major versions of RHEL side by side in the same cluster. This extends the support lifecycle for RHEL certified hardware in OpenShift. And because you choose when to move your machine config pools to RHEL 10, the RHEL major version upgrade event is not connected to an OpenShift version upgrade at the same time. This gives you more control over your upgrade process and isolates your risks. This tech preview release will not be in the very first release of 4.21, like 4.21.0, but is expected in the first or second ZStream update. Next up is Lynn.
Thank you, Mac. To give you a full installation flexibility, we offer 4 onboarding paths, automated for a handoff, opinionated, and best practice setup, full control for those who want to manage their own infrastructures. For users who want a more guided experience, we have our interactive UI, while we offer local agent-based installer for disconnected and air-gapped environments. Next slide, please. Some of the new updates in our installer on cloud providers. For AWS, we've added the M7 instances to our tested types, giving user access to the latest generation of general purpose compute. Next, we've enabled throughput flag for GP3 drives during installation, which allow customer to better protect against product outages. Lastly, we've enabled support for the New Zealand region. On Google Cloud, we're introducing several security-focused features. First, we have custom DNS is now GA, allowing users to bring their own managed DNS and stay compliant with ITAR requirements. Next, we've introduced support for custom Google Cloud API endpoints, enabling private service consumption across VPCs belonging to different groups, users, and organizations. Last, we've enhanced firewall security with fine-grained permissions, allowing customer to predefine rules and maintain least privilege access. On Azure, we're also introduced custom DNS. In addition to that, to align with Microsoft best practices, we now support NAT gateway as an outbound type to prevent SNAT port exhaustion. Additionally, we've added H100 and H200 machine series into our list of tested machine types, ensuring that our customers running AI/ML workloads on the latest generation of TPU infrastructure. Finally, for Google Cloud, we made OpenShift available on Oracle Database Appliance, which is a system specifically for superior performance for Oracle database workloads. Next, on to Michal.
Thanks, Lynn. Let's take a look at some cool features coming down the pipe for our infrastructure platform. Starting with bare metal, we have a big news for day 2 operations. Firmware settings reconfiguration and update are now generally available, along with support for custom CA certificates for BMCs. We also added Dell iDRAC 10 support and the ability to provision bare metal spoke cluster with KubeVirt hosted cluster. Note that bare metal metrics collections is currently in tech preview. Moving to VMware, on top of the news about the GA support for vSphere Cloud Foundation, we are also working on and introducing as a technology preview the feature that allows you to add bare metal node to your existing vSphere OpenShift cluster. On the multi-arc side, we are making sure that you can auto-scale from 0 even in mixed architecture environment. Our IBM friends have also been busy with IBM Power System, adding support for SMB's CSI operator, while the IBM Z-Stream folks have got hosted control plane into the tech preview on our OpenShift virtualization technology. I hope you will enjoy using those features and share your feedback with us. Going to the OpenShift virtualization installer in disconnected and external registry-less environment, which continues as a technology preview in 4.21.z. We are happy to announce that we are adding 6 additional day 2 operators: Loki operator, OpenShift logging, cluster observability, Metal LB, NUMA resources, and OADP. Additionally, for installation, you can now inject your SSH key and pull secret directly into the ISO before downloading it. We also supporting day 2 upgrade using an external registry. Please note that an upgrade without an external registry is on our roadmap and will come in future releases. Now let's check what Gil prepared for us.
Thank you very much, Michael. So for Shift on Stack for 421, we will be introducing the ability to use token authentication in the OpenStack cloud provider. That will enable us to streamline the internal registry service, and it is focused on basically streamlining it with multiple storage backends. At the Rosso front, in feature release 5, which will be kind of trailing 421 in March, we will be introducing for the first time Keystone Federation realm. This will enable us to use a single authentication across multiple OpenStack domains, basically federating the identity service and enabling us to use multiple environments from a single identity pane of glass. In addition to that, we will also be introducing in tech preview the Rosso Lightspeed integration. This integration will greatly improve the administrator ability and user experience, focusing on infrastructure health, resource consumption, and general troubleshooting. This functionality will eventually be evolving into active measures, calling upon the OpenStack workload optimization service to act on potential congestions and hotspots within the infrastructure and mitigating them through workload rebalancing. And that is it for me. Next slide, and on to Marina.
Thank you, Gil. Now let's talk about the OC Mirror, the OpenShift registry mirroring tool for deployments in disconnected and air-gapped environments. We have two important updates here today. First, OC Mirror now automatically mirrors the 6-store signatures to your offline environment. And why does it matter? As we're now utilizing image policy and cluster image policy features to validate the core payload image used for initial install and update on the cluster, this behavior makes verifying Red Hat OpenShift much easier in disconnected environments. Even with the local registry, the signatures remain valid, even though they came from a different registry. Second, OC Mirror will now require the explicit use of flags -v1 or -v2. As we prepare to remove the deprecated v1 codebase in the future, this mandatory selection ensures that your mirroring workflows remain predictable and your automation is fully prepared for the transition to the v2 architectures. Thank you. And next slide, please. Hand off to Ramon.
Thank you, Marina. Control plane security and scalability. And starting on the left with scalability, we've added a configurable event TTL in very large clusters with hundreds of compute nodes. This applies essentially to this type of clusters. The high volume of event data can put pressure on the control plane. And with this feature, you can now tune the retention period for these events to significantly reduce the load on your etcd database, essentially, right? This improves the control plane stability and the performance, again, in very large clusters. So moving to security, we're introducing support for external key management service for etcd secrets. This is a technology preview. We are releasing it in a ZStream release in 4.21. And this essentially enables OpenShift admins to offload encryption keys for the secrets stored in the etcd database to external services. We are starting with support with HashiCorp Vault and AWS KMS, which is the KMS we are developing with. And this ensures strict separation between the encryption keys, where do we store them, and the cluster data in OpenShift, right? Satisfying a critical requirement for high compliance environments. Over to you, Gaurav.
Thank you, Ramon. OpenShift core payload is now 6 signed and 6 signed verified. What does that mean is when somebody install OpenShift or upgrade OpenShift, the core payload that has been pulled from an image registry, first of all, that core payload is 6-store signed, and when it installed on the cluster with the cluster image policy, the image is re-verified. Thank you. And next slide.
Okay, well, hello again. For OpenShift 4.21 on the topic of secrets management, we have a number of interesting improvements. So firstly, we're actually working very hard to improve the usability of OpenShift secrets management operators and make them more accessible. So to that, we've added a number of new tutorials and sample YAML snippets to the OpenShift console as part of each operator's installation payload. This should make our operators much easier to onboard for those folks that are new to secrets management or new adopters. Additionally, in order to reduce the number of false positives during vulnerability scans and minimize our overall vulnerability exposure, all of our secrets management operators are now using the UBI base image. Now, specifically to Cert Manager, we are excited to announce the technology preview availability for Trust Manager, which is an add-on functionality that will allow you to create customized bundles of trusted CAs that you can distribute to your workloads. With Trust Manager, you can ensure that every service knows who to trust without any manual configuration, and it will integrate seamlessly with Cert Manager so that when any CA is automatically renewed or rotated by Cert Manager, the trust bundle is also automatically updated. On the topic of external secrets operator, we are bringing a couple new features in the second release following GA, including better support for custom configurations at runtime, which is a significant improvement that will allow for more flexibility during deployment. Additionally, we have true support for workload identity federation on Google Cloud Platform, and that will be included in this release. Now, thank you, and on to networking and routing.
Thanks, Nick. First, I wanted to say this content by no means illustrates the extent of work that's being done to lay the foundation for some enormous features coming later this year. At the same time, there's also a laser focus on platform stability as well. With that, network observability has a new release, 1.11, that includes additional virtualization test coverage for local net and Mac VLANs. There's also improved DNS decoding illustrated here that shows DNS domain name and class. The network health and alerts console view aids in troubleshooting and is now generally available. And the biggest improvement in this release is that the install is done by default on cluster installation and can be done without Loki or Kafka. The operator's resources can be easily tuned to balance customer metrics, granularity versus cluster resource consumption. And finally, the OpenTelemetry collector can be integrated with Splunk to export metrics and log data directly to Splunk. Next slide. I won't mention all of these updates, but I wanted to point out a key feature for on-premises. VIPs can now be optional by disabling internal DNS records when an external load balancer is in use. And for ingress gateway API updates, TLS route is being integrated in the next gateway upstream release, and support for on-premises platforms is a very popular request and key capability for Red Hat OpenShift AI. Next slide. On to core networking updates. In the area of virtualization, our focus for this release is to ensure that customers can seamlessly move their virtual machines, which have static IPs, from their older provider platforms to OpenShift. For universal connectivity, we give customers the ability to export their pod networks, UDN networks, and import routes from external networks. They will be able to leverage VRF Lite to carry their UDNs in a segmented fashion to the external networks. Next slide. Finally, we'd like to point out our collaboration with NVIDIA for upstream Oven K. This is a very big deal as they're quickly becoming the next largest contributor to the upstream, and will both benefit from this collaboration to ensure customer use cases are addressed. With that, we'll hand it off to Chris for Red Hat Connectivity.
Thank you, Mark. So Red Hat Connectivity Link is really proud to announce the release of version 1.3. This new release brings a lot of new features, hardening of existing features, and begins to deliver on the large items in the roadmap for RHCL. The first of our highlighted features is our new developer portal, which we have built into the developer hub that will be introduced in Dev Preview version 1.3. Second of the highlighted features is the enhanced developer experience, where we are improving the trace logs, observability around policies, and RHCL components to improve quality, runtime, and behaviors of RHCL. We're also introducing the developer preview of MCP gateway functionality, solving a major issue around authentication within MCP communication paths. Also accounting the general availability of core DNS support within RHCL, developer preview of automated DNS failover based on DNS policy. So please check out version 1.3 release of Red Hat Connectivity Link coming in the end of February. Now I'm going to hand it off to Marina and operate a framework.
Hey, thank you, Chris. Moving to OLM. We are now honoring centralized TLS configuration for PQC safety. OLM v1 now adopts the OpenShift API server configuration as its source of truth for cluster-level TLS settings. Next, webhook support in OLM v1 is now generally available. Operator authors can now rely on OLM to manage webhook lifecycles without any bundles modifications. For the users, this adds automated health checks to detect misconfiguration and easier service port troubleshooting. Looking at our technology preview functionality, we have two features that are gated behind the tech preview no upgrade cluster mode. New for this release is the OLM v1 view in the OpenShift console, and we also continue to support operators packaged using own namespace and single namespace install mode as tech preview. This functionality ensures accurate operator scoping by automatically injecting the correct watch namespace environment variables into the deployment manifest. And next slide, please. Now let's look at how this change comes to life in the OpenShift console. You have already noticed a shift in navigation as we merged developer view with the admin view in previous releases and introduced a unified ecosystem menu where the software catalog now replaces Operator Hub. As part of this reorganization, Helm also moved under the ecosystem header to centralize all your software management in one place. If you switch your cluster to Tab Preview No Upgrade mode, OLM v1 option will become available to you on the console. Note the toggle button for easy management if you want to switch back to OLM Classic. Please give OLM v1 a try and let us know what you think. Thank you, and next slide, hands off to Gregory.
Thank you, Marina, and hello, everyone. So let's review what's new in storage. So on the driver side, on your left, we are GAing support for Azure File, CSI Snapshot, and clones. This covers both the SMB and NFS protocols. On the Google side, to answer some customer security requirements, we are offering an option to reduce the scope of GCP permission required by the PD driver. This only applies to clusters deployed with workload identity federation. Lastly, we're happy to add support for PowerPC 64 to the SMB CSI driver. All right, now on the core side, on the right, we're introducing, as mentioned earlier, volume attribute classes as fully supported. This new object provides a way for administrator to describe classes of storage. And these classes, they usually refers to QoS settings such as IOPS and throughput, but in theory, you could put anything in there. It's just an object in which you can put attributes, but they are usually QoS based. When it's defined, you can apply these volume attribute classes to a PVC. And if needed, you can also change the class of an existing PVC without any downtime. Please note that this feature is driver dependent, and for now, only GCP PD and AWS EBS are supported. Lastly, we are graduating a new feature as tech preview. It's called Mutable CSI Node Allocatable Property. That's a long name. This allows a CSI driver to dynamically update the node level volume attachment limits without restarting kubelet. For now, it's only applicable to EBS and is completely transparent to the user. Next slide, please. All right, now on to OpenShift Data Foundation. So in 4.21, we have 4 major updates. So one, for regional disaster recovery, we are introducing support for multi-volumes applications and full support for multis on primary and secondary clusters. We will also start a hybrid RDR journey with on-prem and Azure support. On the object side, consumer will get access to an object browsing interface without cluster admin privileges, and the admin will be able to manage those through identity access management. New thing on the external clusters, they can now use Replica 1 and IPv6. There is also a new health overview dashboard that is introduced. It provides more holistic view on storage and networking. And last but definitely not least, we are introducing GA support for ARM architectures. And that is it. Thank you.
Yeah, thank you, Gregory. Next slide, please. Yes, I'm going to talk about the functionality, in telcos where seamless network delivery is a key concern. Basically, to achieve, high-end predictable performance, network function are typically built on top of DPDK framework, which necessitates, dedicated CPU core to the applications. However, in a CNF environment, the DPDK applications run within a container, and today Kubernetes, currently lacks a way to both request dedicated cores while also allocating, a small amount of additional shared CPU capacity. for such workload. As shown in this slide, I mean, since hybrid threads are always allocated in pairs, assuming CPU 4 through 7 are dedicated to DPDK, and CPU 2 and 3 are reserved exclusively for lightweight interruptible operations such as logging, console access. In this scenario, these new features will allow interrupt to be handled on CPU 2 and 3, effectively adding processing capability to the kernel and storage stack. This capability is especially beneficial in high-density environment, where you like to pack the maximum number of DPDK pods per servers for your networking, while at the same time, you would like as well, to be able to seamlessly process, those interruptions. And I hand it to Rob. Next slide.
Thanks, Harry. OpenShift telecommunications customers requested a feature set to allow for changing the network of a single node OpenShift node. These reconfigurations are to the network properties of the NIC port connected to the physical network, and they affect how the node is accessed on the network. There are a variety of use cases that this feature set enables, but I'd like to highlight two that best demonstrate the value of this feature. Imagine a national 5G network with IPv6 addressing. A disaster strikes and the national IPv6 network goes down. There's urgency to restore the provider network, and the following disaster recovery procedure might be as follows. A fleet of technicians delivers Starlink routers with satellite antennas to all of the far edge sites. The routers have IPv4 addresses written on them, so the new network settings were not known in advance. The technician recables the OpenShift node from the IPv6 cell site router to the Starlink router, and the technician runs a script on the OpenShift node and reconfigures it with the new network settings. The result is that the national cellular network is now restored on the satellite network and can provide service until the IPv6 network is restored. The second scenario, imagine a telecommunications operator needs to reconfigure part of their national network. They need to re-home 20 single node OpenShift instances to a new VLAN. They plan the network change on the cell site routers such that the new VLAN is also available to the OpenShift node. And then the telecommunications operator uses ACM policy to push the new VLAN change to the nodes, and they are then rehomed to the new VLAN. The old VLAN can then be removed from the cell site router configuration, and the operation is complete. By way of enabling this technology, we also enabled dual stack image-based install, dual stack image-based upgrade, and dual stack image-based break fix for single node OpenShift. Please see the slide on the screen to see which functionalities are tech preview in 421 and which are developer preview. We are targeting GA for all these features in OCP 422. Please try them now and give us feedback. With that said, I'll hand it over to Daniel. Thank you.
Thank you, Rob. Finally, let's look at Red Hat Device Edge and Microshift, which is our small form factor Kubernetes distribution for edge devices. This release is packed with new features, as you can see on the slide. Let me highlight just 3 of it. First, we are simplifying SR-IOV, single root I/O virtualization, for use cases that require advanced networking. You could use SR-IOV with Microshift already today, but it required a lot of manual configuration. With this release, you can add the optional Microshift SR-IOV package to your deployment and simply use custom resources to configure it like you're used to do on OpenShift. Second, let's talk about hostnames. At the edge, you cannot always easily configure change DNS entries. Sometimes a simple good old etc host files entry can save your day. You can do this now with Microshift. The name in the host files you have on the outer operating system host actually resolves from inside a pod to allow easy communication to other services. And last not least, it's worth mentioning that the Microshift upstream community experience was greatly enhanced. You can now install Microshift with a single command line and no need for a Red Hat account or pull secrets as it used to be in the past. This is now a true upstream community experience. Check it out on microshift.io if you're interested. Okay, thank you for staying with us till the end here. Videos and slides will be available on the What's New in OpenShift webpage. Link is on top of the list here. And on behalf of the whole team, thanks for joining. Take care and goodbye.